All right, now let's keep talking about experiment, and then there's another design we want to talk about. That is called within participant or within subject. So we just talk about between, right? Now within is each participant is tested in all conditions. So for example, if I want to test, let's come back to the drug, right? So in within, the participant will take the drug first, and then see the improvement, and then take the placebo and see if they improve. Okay, same participants take the drug and then the placebo. All right. Now within has some advantages over between the design. So the good thing is provides a maximum control of extraneous participant variable. So because it's the same person, right? You're comparing the same people. Yeah. Instead of like between participants, they are actually different people. So you will see a lot of variability, right? But within, well, there's the same people, so you don't have to worry about people. They might be hugely different. Yeah, they're same people. However, there are some problems with this design. Uh, the main thing is they can result in carryover effects, and there are a lot of different carryover effects. Carryover effect is an effect of being tested in one condition on participants' behavior in later conditions. In other words, the first condition influences the later. There are different types. So first, the practice effect. So participants perform better on a task in later conditions before just because they had a chance to practice. Or fatigue effect. They got bored or they're tired, right? Or context effect. Being in one condition affects how participants perceive or interpret their task. So for example, if you are asking, I don't know, how much they think people around them support them, right? And maybe you ask them about their friendship first. But if you ask the friendship first, then this might influence some of their later answers about how they perceive people support them. Because if they have a lot of good friends, they have some good friends, and they happen to think about some this good friends, then later they are going to score higher on the support. On the other hand, if they happen to be right depressed or happen to have an argument with some friends, then later scores are going to be lower. So to try to solve a carryover effect, how do you do that? All right. One really smart way is to counterbalancing, varying the order of conditions across the participants. In other words, so for example, you will have half of the participants do maybe the questionnaire, right? If your experiment involves questionnaire, so the order will be the participants fill out the questionnaire 1, 2, and 3 on this order. So you have participants finish at 1, 2, 3. The other half, let's start with number 3. So 3, 2, 1, right? So it will counterbalance. Now, two things that counterbalancing can accomplish is first, there's no longer a confounding variable because you balance out. And if there are carryover effects, maybe you can detect it. Because if you see these two conditions are hugely different, then you'll see, wow, this carryover effect is really obvious. Right. All right. So now, which one is better between participants or subjects or within subject? Now, the good thing about between is it's simpler, conceptually simpler, and actually when you analyze the data, it's much simpler, and it requires a less testing time per participant. Because within, you probably need let them wait for a while in between. Avoid carryover effect without the need for counterbalancing. Now, the good thing about within, you control more extraneous variables, reduce the noise in the data. Well, actually, there's another one I forgot to put it. It's you need much less participants. So, for example, if you only see, if each condition you need 20 participants, and you have in total 2 conditions, then for this design between participants or between subjects, how many do you need? You need 50 because you have 2 different groups. But for within, you only need 25, right? Because everybody is going to experience some of these 2 conditions. All right, so if necessarily, we can do both. Actually, my dissertation is, I do them both. So finally, conducting experiment, you need to standardize the procedure. As we're talking about as a whole, no matter between or within, because it's important to standardize the experimental procedures so you can minimize extraneous variables. If you act, as a researcher, you act a certain way, and in another condition, a control condition, you add another way, then when the result come out, you don't know if it is because of the IV or because of the researcher act in a certain way, cause the participants to respond in a different way, right? So experimental expectancy affects is experimenters' expectations cause the result to be consistent with those expectations. So go back to the drug example. If I, as a researcher, knows this is the drug, which is a drug, which is a placebo, and when I give the drug to the participant, I might hint say this is a real drug. It should work on you. And they will say, oh, this is a real drug. Okay, so now the placebo effect is even strong. They are going to comply to the expectation. Right. So the solution is double blind, as I mentioned. Double blind means what? Participants don't know who is taking what, and the researchers don't know who is taking what. Conducting an experiment, after you collect the data, you need to keep the records really, really well. It's essential to keep good records when you conduct experiments. Now, usually we keep the record, we enter the data, and when you enter the data, you gotta be careful. Sometimes you enter just one wrong number. So instead of 9, you enter 99. It will hugely just skew the data. So when you analyze the data, if you see an outlier, some abnormal activity, you're gonna go back to the raw data and see if maybe people enter the wrong data. Sometimes before you conduct the experiment, you don't know if that really will work. So, for example, you don't know if the manipulation, for example, high anxiety, low anxiety, if that will really work. What you need to do is a pilot study, right? A small scale study conducted primarily to be sure the procedure works as planned. Remember this. Remember the Murphy's Law. Nothing is as easy as it looks. If you think it won't go wrong, it will. That's why you gotta be really, really careful. Do the pilot testing to make sure everything works before you go into the real experiment. Because if you go to experiment and you screw up just because I didn't control something you could have controlled, all the money and time, and energy, whatever is wasted. All right.